All right, so horizontal asymptotes are another really important feature of your rational functions. In order to find the horizontal asymptotes without using transformations like we were in previous lessons, we have a few rules that we have to know. There are three possibilities. First things first, we have to know about the degree of polynomials. And so just a quick review on that. The degree is the largest power of x. Within the polynomial. Okay, so we have three possibilities then, since our rational function is made up of a polynomial on the top and a polynomial on the bottom. The first case is that the degree on the numerator could be smaller than the degree on the denominator. So that's this case right here. So if you've got a low degree on top and a high degree on the bottom, then your horizontal asymptote is y equals 0, always. This is sometimes referred to as a proper rational function, kind of like a proper fraction. In a proper fraction, the numerator is smaller than the denominator. And so in a proper rational function, the degree of the numerator is smaller than the degree of the denominator. Okay, so we have an example over here to the side. The degree of our numerator here is 1. It's a linear polynomial. And the degree of the denominator is 2. So it does follow that case. We've got a lower degree over a higher degree. Therefore, the horizontal asymptote is at y equals 0. The second possibility is your rational function could be y equals a polynomial with a particular degree over another polynomial with the same degree. So if they have equal degree on the top and the bottom, then your horizontal asymptote in that case is going to be y equals whatever the leading coefficient is of the numerator divided by the leading coefficient of the denominator. So for this one, we've got an example again. The degree of the numerator on this one, the largest power of x, is 1. The degree of the denominator, again, the largest power of x, is also 1. So therefore, this does fit that case. Same degree on the top and the bottom. They are equal. So our horizontal asymptote is going to be y equals, and then the leading coefficient to the numerator, which is the coefficient of the term that gives you the degree, divided by the leading coefficient of the denominator. So that would be the coefficient of the term that gives you the degree again. So that's a -8. Now, whenever possible, you should reduce those fractions. So this would be y equals, when you've got a negative anywhere in a fraction, it's best to move it either to the front of the fraction or to the numerator. It's best not to leave it in the denominator. Then, of course, 6 and 8 do have a factor 2 in common, so we can divide both of those by 2, and that would give us y is equal to 3/4. So our horizontal asymptote would be y equals 3/4. The third possibility would be if the degree of the numerator is larger than the degree of the denominator. Okay, so if the degree of the numerator is larger than the degree of the denominator, then there is no horizontal asymptote at all. Again, we have an example for this one here. The degree of the numerator on this one, largest power of x, is 2. And the denominator, the largest power of x, is 1. So that means the degree on top is greater than the degree on the bottom. So when that happens, there is no horizontal asymptote. So I would just write none for the answer there.